If space is not so colorful, then what color is the universe really? When most folks view space images, the first thing that usually comes to mind is OMG, just wow. Look at how pretty those bright colors are. But then some say, this isn't what space looks like. And these pictures are not real. We understand they are not, but you should not be upset about the simple things like this. If the colors were really bland and boring, I wouldn't be fond of examining those pictures. Paul Sutter, an astrophysicist, has spoken about this problem and requested individuals to stop complaining. He talked about how essential it is for NASA to enhance the quality of the pictures, not to get more fans or shares, but because it's essential for scientific research. Just a little assistance might assist them in comprehending a lot of the complicated things that they wouldn't be able to do anyway. Researchers take pictures of stuff in space and learn how it works, and some higher contrast here or a little brightening over there can help us understand complex structures and relationships within and between them, he writes. So don't blame NASA for a little photo enhancement touching up. They're doing it for science. Check out this picture. What could you see? Can you think of anything? You can see that this is a space photo because it looks like it was taken from a telescope. This is among NASA's most famous space pictures, but you've likely never seen it before. How did I learn this? That's simple. It's black and white. You may still not understand this, but this is how every other space picture is made. Also, most telescopes can only take black and white images. The Hubble telescope is likely the most well-known of this. Now, take a look at this image with colors. This is mostly similar to the previous one, but this picture of space is more likely to be recognizable to you. It's called the Pillars of Creation. It's a photo taken by the Hubble telescope of the Eagle Nebula, which is 6,500 light-years away. This image is a perfect example of how space photos get their colors. But what exactly is this procedure, and what else does it do besides adding color to pictures of space? Let's dig a bit deeper into it. Before we look at how colors are used in space pictures, we must know how light performs in the cosmos and how we see it. Everything we understand about the light frequency range in the universe, from radio waves to gamma rays, is depicted in the picture above. But humans can only perceive and understand a small part of this spectrum, called visible light, because the human eye does not see most frequency bands of light. But the light humans see goes from red at the lowest frequency to violet at the maximum frequency. We can detect this light due to cells in the back of our eyes called cones. These cells use the light that objects reflect to figure out what color they are. Our retinas have 3 kinds of cones that can see various shades. Each kind can pick up a distinct spectrum of light. Also, each cone can grab light waves that are lengthy, medium, or narrow. This was approximately the same as the 3 colors, red, green, and blue. So, these are called the primary colors of light and serve as the foundation for all the wavelengths of light we perceive. You've likely heard of the RGB model, in which varying quantities of red, blue, and green are mixed to make a variety of colors. This framework is a key component of comprehending how black and white space photographs are turned into color. So, now we know how light works. Let's look at how it happens. The majority of the images you see of space come from Hubble, so we'll use it as an example of the camera. Initially, the telescope must be well focused. Telescopes generally look at things that are extremely far away, so the telescope must take the correct steps to capture a nice photo. The camera then begins to capture the image. The telescope separates the light it sees into long, medium, and short waves. For each range, light is picked up by 3 different picks. The procedure, nevertheless, it takes a bit of time. There is a specific period between each frame, some say 1,000 seconds. Also, Hubble is always going around the Earth at 17,000 miles per hour, so it will probably take more than one orbit to get all the frames it needs. After every photograph is taken from each range of wavelengths, every range is given a tint relying on where it is located on the color spectrum. This color is usually red, green, or blue. This is called broadband filtering, because the light that gets the camera is split into a large variety of long, medium, and short wavelengths. Afterward, programs like Photoshop combine the various illumination wavelengths from the frames into just one. After a few tweaks, the picture is done, and you'll get something like the picture above. What else could be done with the procedure? Viewing space in color is incredible. But scientists can also utilize the procedure for each thing. For instance, researchers can find gases and find out where they are in the universe by using broadband filtering called narrowband filtering. If researchers looked at what was left after a supernova exploded, they might discover what gases remained or were released. Because different gases absorb distinct wavelengths of light, the shades given to them during the photocoloration procedure are essential. Astrophysicists can learn more about how gases are spread out in the universe by looking at how common gases show up on the spectrum. This could prove alien intelligence or other galaxy clusters and systems. Galaxies don't have as many colors as we believe they do. So yes, if everything we view through the Hubble telescope, which we adore, is enhanced, so what's the color of space? Okay, presently, there's no proper response to this question because it's challenging to determine color of space. Everything varies depending on what kind of eyes you're gazing at it. Space gives off many different types of light, some of which we can perceive and others we can't. Even the Hubble Space Telescope, which has taken most incredible photos of space we've ever seen, can't perceive colors and can only take black and white images. A charge-coupled device is used in the Hubble telescope. Creating color images out of the original black and white exposures is equal parts art and science. The Hubble site explains, "We often use color as a tool, whether it is to enhance an object's detail or to visualize what ordinarily could never be seen by the human eye. This describes why the majority of pictures we see here are blue or red, the only colors our eyes can see. Although this is common, scientists still want to understand which portion of space are putting a UV, X-rays, or gamma rays. They then give these sections shades so we can observe them with the naked eye. Elements, when they're heated, will glow in very specific wavelengths of light. Right, Sutter? Sometimes that light is within human perception but will be washed out by other colors in the picture. And sometimes the light's wavelength is altogether beyond visible. But in either case, we want to map out where that element is in a particular nebula or disk." He adds, "So, scientists will highlight that feature to get clues to the origins and structure of something complex." What will happen next? Our cosmos is a vast void brimming with things we will never encounter or know. We've only investigated about 5% of the universe, but we intend to keep going. In the meantime, this broadband process could help individuals in numerous ways, like discovering planets where people could live and learn more about our vast galaxy. We push the limits daily, develop new ideas, and overcome challenges. Innovation hasn't stopped and won't stop because people will always desire to fix the world, and I can't wait to see this happen in the coming years. Just like Stephen Jeffers says, innovation is the unrelenting drive to break the status quo and develop a new where few have dared to go. Thanks for sticking around till the end of the video. If you enjoyed this video, smash the like button and subscribe to our channel for more awesome videos just like this.